Let's now consider the first example of counting how many primitive operations that a given algorithm is going to take in order to execute to completion. And you have to keep in mind, we want to think about the worst case scenario. You want to think about every line of code is actually going to be triggered by such an input, such that it's going to execute for as many times as it possibly can. So that's something we want to keep in mind. Okay. Especially we got conditional over here. So you don't really have to worry about, maybe sometimes it will be executed and sometimes it will not be. For this particular kind of practice, we simply want to consider it's going to be executed for every iteration of the loop. And then the body of the if branch will just be executed as well, right? The worst case scenario. All right, so the method over here, it shouldn't take you too long to figure out. It's actually trying to calculate the maximum in the input array, right? I'm not going to explain the rationale for this code. If you got any trouble understanding logic, you can definitely reach out to me. Let's save the time. Of course, you can pause the video and think about why it is calculating the maximum of the input array. But what I want to explain over here is about input parameters over here. Rather than simply taking just the input array, I also include another extra input over here. That's for the convenience of our analysis. Let me just explain, first of all, how we are supposed to use this particular method. Okay, so what you can think about is like this. Okay, so what we get is we got find max. Okay, so this, of course, it returns an integer, and the integer array A. I'm just declaring this the method over here just for illustration, and then also integer n. Okay, so what you can assume is whoever is going to call the method is guaranteed they're going to pass the length of the array. Assume to be a.length. You simply assume. For example, let's say we have an array. Let's say sequence. Integer array, let's say sequence over here. And then it's simply, let's say we want to find out the maximum in this particular array. Let's say 2 minus 1, 3, 1, 10. Well, apparently you can see the maximum is 10, right? Eventually, that's what we expect the method to return. So how do we use this method? So what you will call is, you're going to say find max, and then you're going to pass the input array, and then you're also going to supply the length of the array. It's something that's expected from the caller, right? So of course over here you can either say 1, 2, 3, 4, 5. You can simply put 5 over here. That's one way to use it. Or you can simply, rather than giving a concrete number, you can always say the input array, the length. Either way, you'll see how convenient this is actually for us to really draw the analysis conclusion later. All right, so that's about how to use the method, just to explain to you. But you will see something similar as we go along throughout the course. All right, let's now go back to this method over here. What I want you to do is, you can feel free to pause the video, even though that's your first example, but I will still really encourage you to really pause the video and at least try to grab a piece of paper and then to count for every line of code, excluding line number 1, of course. There's no execution for line number 1. Starting from line number 2, 2, 3, 4, 5, 6, and 7. All these lines, think about at the runtime in the worst case scenario, how many primitive operations will actually be executed. Of course, if the same line over here is going to, for example here, if that line is going to be executed for multiple times, you have to include them as well. For example, if this is apparently a primitive operation, if that one is going to be executed for 10 times, in that case you have to say 10 primitive operations, right? All right, you can now pause the video and do the exercise. Assuming that I have done that, the exercise, let's now go over the answer together. Okay, let me now switch to the notes. And for the complete solution in the written form, you can also look at the slides. But I would suggest we go over the solution together with you completely, step by step. This is the same amount of code over here. And let's now try to answer 2 questions in order to help us derive the final answer. Question 1 and question 2. Okay, question 1. How many times has how many times will line number 3 be executed? Line number 3 is simply this particular relational operation over here, right? You can see here. So I strictly less than n. So this is a relational operation. Itself is a primitive operation. So it will take a constant number of times. So it's considered as a one primitive operation. However, since it's now included as the exit condition, right? Sorry, it's now included as the state condition. The condition when as soon as it becomes false, you're going to exit from the loop, right? It's a very it's a very basic understanding about the for loop. So now the question is, how many times in the worst case will this condition here be executed? Right? That's a question. Right? Let's now see. Okay, and let me remind you remind you very quickly about how the loop is supposed to be executed. Let's say this. If you try to trace the loop, you have you can trace according to the loop counter I, right? The loop counter I will start being 1. Okay, so that's going to be 1, and then 2 for the second iteration, 3 for the third iteration, all the way to certain bits, right? And now, what's going to be the last time you're going to evaluate this particular condition over here? Well, let's say, for example, let's say the array is like this. Let's say A, input A, is simply an array of maybe size 5. 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, I don't even need to worry about the contents over here, right? Let's this loop is actually going to go from the beginning until the end. It's definitely going to run 1, 2, 3, 4, 5 iterations. That's what we know very well. And you want to know about the loop counter. What's going to be the value for the loop counter? The loop counter will stop being 1, and then it's going to be 1. Let me just over here. Okay, so it's going to be 1, 2, 3, and then it's going to be 4. And oh, by the way, what's n over here? The n over here is going to be a.length. 1, 2, 3, 4, 5 is going to be 5, right? Okay, just to remind ourselves about how to use the method. And what will be the value for I if you try to trace the for loop? It's going to be 1, 2, 3, 4. Can it be 5? Well, you want to be careful over here. Okay, when we actually do the tracing, you want to think about how many times this particular condition will be evaluated versus how many times the body of the loop is going to be executed. Let me just try to use different color over here. You can see I'm trying to use the green and also the pink. The green part is about how many times this particular Boolean condition is going to be executed versus how many times the body of the loop is going to be executed. There's a fundamental difference over here, because here, when you try to evaluate this particular Boolean relational operation, it can be either true or false. Agree? And then over here, if you're able to execute this particular body of the loop for once, that means at the moment, this Boolean condition cannot be false, because otherwise you would have already exited from the for loop, right? So that means whenever you're able to execute the body of the loop, that means this Boolean condition here must be true. Okay, let's well, it's a very quick reminder about the facts for the for loop. So that means over here, when I is actually 1, 2, 3, 4 over here, so these are the 4 values where I less than n evaluates to true, right? Because n is actually 5. So 1 less than 5, 2 less than 5, 3 less than 5, and 4 less than 5. They're all true. The very last evaluation for this particular Boolean condition, right? When you try to do I less than n over here, 5 less than n is going to be false. It will still be this will be evaluated, and then we know that we should really bypass the body of the loop, right? That's exactly how the loop should be executed. All right, hopefully so far you're okay. And now we have already know the answer for both over here. Number 1, how many times will we actually execute I less than n? Well, it's going to execute for this many of times where it's going to be evaluated true, and the final time it is going to be evaluated to false. in this particular example. So what should we do? What you should think about is how many times will that evaluate to true, and plus 1, the only time that it is going to evaluate to false, right? And let's see this. Since we start the index with 1, so that will be the second index rather than the first index, right? So in this case, it can be second index, third index, fourth, and fifth. And how many elements do we have in the array? N, at length, right? And then we are excluding the very first index because we're starting with 1. So it should be n minus 1. All right? Hopefully you're following the reasoning. So n minus 1 times that it is going to evaluate to true. And it's only going to be one time that it is going to evaluate to false. In total, it's going to be n minus 1 plus 1, okay, which is equal to n. Okay, let me just do a little bit more annotation for you. It's really important for you to understand this particular example completely. Otherwise, you might actually struggle with similar ones. So n minus 1 over here, these will be the times where I less than n evaluates to true. And this part over here, the 1 over here, is the only time where we know that we have to exit from the loop. I less than n evaluates to false. Okay, so that's n. That's question number 1. So what about question number 2? How many times will the loop body from line number 4 to line number 6 be executed? Well, this one here will just be whatever this value is, minus 1. Why minus 1? Exactly the 1 over here, because when the very final time where this particular Boolean condition here evaluate to false, we are not going to execute the body of the loop anymore, right? Because we should exit. If this condition here never evaluate to false, what does that mean? That means you got an infinite loop, okay? Of course, we're assuming that you don't really have any like a break, or maybe like a break statement, for example, right? It's not a very good practice in terms of software engineering. But anyway, all right. So this will just be n minus 1, n minus 1, and again, the 1 over here is really about the time where I less than n evaluate to false. That means to exit from the loop. And the n over here is about how many times the state condition over here is going to be evaluated. It's going to be exactly n, but you got to say minus 1. Okay, so this will be n minus 1 for this particular example. Is actually going to be the number of times that you're going to execute the body of the loop. It's very important to understand these two questions and their answers first before we can move on to the analysis. All right, hopefully you're fine so far. Let's now move on further to actually talk about how we can calculate line by line about a primitive operation. So now it will be faster for us. Okay, let's now go over line by line. Okay, line number 1. What I really meant to say was line number 2. Okay, for this line over here, how many primitive operations do we have? Well, this one over here, you can see we got a variable assignments over here, and also we got array indexing over here. So we got 2 in total. And this line is not in the context of some iterations, so it will just be itself. So it will be 2. Okay, so I'll put 2 over here. Okay, and the next one, let's say the loop header, line number 3 over here. How many times how many primitive operations do we have? Well, this one you got to be careful. For sure, we got the variable assignments, and also we got this relational operation, but we got to be careful because this particular relational operation, as we try to explain, that will be the answer to question 1 here. It's not just going to be executed once in general. It depends on what n is. Depends on what the size is for the input array, right? As we said before, it's going to be n. All right, so that's going to be 1 times n. The 1 over here means it's a relational operation, so itself it's a primitive operation. but it is going to be evaluated n times. The first n minus 1 time is going to be true, and the last time is going to be false, right? So it's going to be in total n, and plus the initialization of this particular loop counter, so that's going to be n plus 1. All right, so that's going to be n plus 1. So n plus 1. So that will be line number 3. Right? You can also see the same annotation in the slides. All right, let's now go further. And for the remaining, for the next 1, 2, 3 lines, notice that they are in the context of the body of the loop, right? Let me just make it more explicit for you. So we are now talking about these 3 lines over here. They're all going to, the number of primitive operations in each line depends on how many times we're going to execute a loop, right? Even for the first, for each iteration, the number of primitive operation is something you can analyze over here by going to multiply by how many iterations you're going to run for the loop. Okay, let's see the first one. Line number 4. Line number 4 over here. Let me make it thicker. Line number 4. How many primitive operations for each iteration? So array indexing. Okay, array indexing over here, and also relational operation, and this is simply just some variable accessing which we don't really count. Okay, so that will be 1 plus 1 over here. And how many iterations do we have? Well, it's exactly the answer to the second question about how many times the body of the loop is going to be executed. So it's going to be 2 times n minus 1, right? It's going to be n minus 1 multiplied by 2. Okay, again, we have to really split whenever you're considering a line in the context of a loop. You have to divide the derivation into 2 steps. Step number 1, think about for each iteration how many primitive operation will be involved. In this case, array indexing and relational operation, so 2. And then step number 2, you have to think about how many times in the worst case this line will be executed. In that case, that will be the answer to question 2, which is n minus 1. All right, and let's follow the same pattern. What about line number 5? Line number 5 over here, right? It's you can feel free to pause the video and think about the answer, but I'm gonna move on. Okay, variable assignments and also array indexing, right? So 2. Each iteration takes two primitive operations, but how many iterations do we have? Well, answer to question 2, n minus 1. So we still got 1 and 2. So that'll be n minus 1 iteration for each one of them is going to take 2 primitive operations to execute. All right. What about line number 6? Line number 6, not that tricky, but you just have to know exactly what I++ really mean. Right? So let's now take a look. I++ simply means it's like a shorthand for I is assigned to I plus 1. As soon as you see this, you will know how many primitive operations you have. You can see that number 1, it's the I plus 1. That's the arithmetic operation. And number 2 is going to be the variable assignments. We got 2 in total. So it's 2 primitive operations. Okay, similar. And how many, so for I++ over here, let me just be consistent. I++ over here, as we try to derive over here, is actually 2 primitive operations. And how many iterations do we have? Similar, right, as before, n minus 1. So that'll be also n minus 1 multiplied by 2. All right. Finally, let's now look at the last line, return current max. And notice that this line is no longer in the context of the loop. It's outside the loop already. So we don't have to consider the number of iterations. So what about the primitive operation here? It will be executed only once. Well, it's a return statement. As simple as that. Just one single primitive operation. So that'll be just 1. So after calculating line by line, right? So now we can add them up together. So that'll be the final answer. So let me try to do them over here. Let me use the purple, right? So 2 plus n plus 1 plus, and you can see for the next 3, they can be factored out for by n minus 1, right? Plus n minus 1 multiplied by 2 plus 2 plus 2. That'll be 6. And then plus the final one is simply just 1, right? Okay, let's do a little bit math, shall we? So n plus 1 plus 2, n plus 3, plus, and let me multiply 6 into it, 6n minus 6, and then plus 1. Okay, let's now do one more. So n plus 6n, 7n. 3 minus 6 minus 3 plus 1 minus 2. So that should be the final answer. 7n minus 2. All right, so that's the complete derivation steps for you. Okay, study that carefully, and then you will be able to actually do similar problems in the test or in the exam. All right, so that's the written form for what I just actually illustrated to you. So I would suggest don't just look at the final ones and pretend you actually knew how to do it. You have to make sure you understood what I did and redo it again, right? But again, it's really important for you to understand about the insights by answering these two questions. I think that's a critical part. That's why I spend so much time trying to visualize the execution for you. Okay, so that's the final answer over here, 7n minus 2. All right, and let's now try to do very quickly a second example.